Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 3 on startup procedure of fluidized catalytic cracking unit. Okay, before my lecture I used to read a Quranic verse. قال ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي اللهم ربي زدني علما. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue, that they may understand my saying. Allahumma rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay. Key takeaway points from lecture number 2, startup procedure of fluid catalytic cracking. Okay, today we are going to discuss charge oil to the riser, reactor riser. Number 2, operations of catalyst cooler, line out the fractionation section, gas concentration section, which includes air-free vessels, start cooling water and overhead condenser, start wet gas compressor, inventory vessels with gasoline, heat up the steeper and debotonizers, introduction of a feed. These will be topics we are going to discuss today on my lecture number 2, startup procedure of catalytic cracking unit. Okay, FCC unit startup, charge oil to the reactor risers. Fill the bottom steam generators with a boiler of feed water to prepare them to produce steam. Number 2, adjust the bottom cycle flow through and reactor bypass slide to 5% to design feed rate. The bottom cycle meter is used because a flow of 5% of the design is too small for the normal feed system to accurately control. Number 3, begin oil flow to the risers or through the bottom recycle meters. Sending oil to the risers is done by switching into normal position. This will open on and off, work like FCC valves. Note, after cutting in oil, catalyst circulation must be increased to maintain the reactor temperature above 400 degrees Celsius. That is 900 degrees. Should the reactor temperature drop too low, feed can be reduced until the temperature increase again. Initially, the regenerator temperature will drop until the catalyst containing a coke enters the regenerator, maintain the combustor temperature in the range of 660 degrees Celsius to 675 degrees C. As soon as the main column bottom's level begins to drop, begin raw oil feed into increments of 10 to 20%. Number 5, the low flow rates will be difficult to control, and at first it may necessary to go through the control valves bypass. Take care to maintain control of the catalyst circulation and reactor and regenerator temperatures. If upsets occur, it may be necessary to hold or even reduce the raw oil charge rate. Remember, it is advisable to increase the feed to the reactor to 50% of the normal capacity within 1 hour to avoid any major catalyst carryover to the main column. Okay, lecture number 2 on fluid catalytic cracking unit. Okay, operation of the catalyst cooler. The cooled catalyst slide valves must be closed and fluidizing air must be in operation before catalyst is loaded to the regenerator. The air prevents the catalyst cooler air lenses from plugging. To avoid any thermal shocks, the water circulation through the cooler should be started before the regenerator is heated up. Keep the cooled catalyst slide valves closed position. Number 3, when raw oil is fed to the reactor risers, the production of the coke will start. The burning of the coke will increase the catalyst temperature in the regenerator. Adjust the opening of catalyst cooler slide valves with the increase of the coke productions to keep the regenerator dense bed temperatures below 719 degrees Celsius. Okay. Next, we are going to discuss line out the fractionation section. Okay, line out the fractionation sections. As the main column bottom temperature start to rise, start steam production as possible with the main column bottom's steam generator. Number 2. As the main column heat up, the top circulating reflux will start to increase, showing that there is increasing internal traffic in the column. Slowly begin a side cut circulation flows to adjust the column heat balance. Adjust the side cut and bottom circulation flow in order to maintain a good top reflux flow. Number 3. As the main column heats up, warm up the steeping steam line to side steeper. Start a steam flow to the LCO steepers and begin a LCO flow to the steepers as LCO become available. Pump the steeper product to storage using the light cyclic oil product pump. When the LCO product is an acceptable quality, route it to unit and for further processing and the LCO flushing oil header. Start up the heavy naphtha steeper by putting the heavy naphtha steeper's reboiler into the operations. Pump the steeper product to storage using the heavy naphtha product pump. Number 4. As gas is produced by cracking, it will be necessary to slowly load the gas concentration unit gas compressor and put the overhead receiver of pressure control in operation. Adjust the compressor's suction butterfly valves necessary to build discharge pressure and keep the compressor out of surge. At the same time, the gas from the fuel system to LCO steeper can be shut off. Number 5. Always make sure that there is enough bottom circulation to prevent the main column bottom from coking. Use hot bypass flow to maintain a flow rate. Okay, gas concentration section. The gas concentration unit will normally be started up in conjunction with the startup of the FCC unit. Startup procedure will therefore assume the gas concentrations vessels still contain air which must be removed. Purge air from the primary absorber, sponge absorber, steeper, high pressure receiver, debotonizer, naphtha splitter, and associated lines and equipment in accordance with the normal refinery operating procedures. Okay, first, if steam is used to purge air, the certain wet gas compressor is blocked to prevent steam from entering the compressor. Connect steam to steam out connections at the bottom of each vessels or convenient low point on the vessel or associated piping. Number 3, open the top vent and begin steam. Injections continue steam out until a good plum of steam is visible at the outlet of each vessel. During the steaming, drain condensate from vessel's low point and connected a piping such pump suction lines. Number 5, after the vessel have been adequately purged, reduce the steam flow and begin the addition of the fuel gas or an inert gas such as nitrogen. Close the vent and slowly stop steam injections. Maintain a positive pressure in the vessels at all times to prevent wrong vacuum as steam condenses. Number 6, continue to drain all condensate from the vessels. Increase the vessel's pressure to nearly operating pressure. If feasible, always check for flange leak, etc. Okay, next is start cooling water and overhead condenser. Okay, start cooling water and overhead condenser. Start a moderate flow of cooling water through the water-cooled exchanges. This includes such items as the compressor interstage, a trim cooler, high pressure trim condensers, primary lower and upper intercoolers, sponge absorber lean oil cooler, lean gas coolers, debotanizer, a bottom recycle, a trim cooler, debotanizer, a trim condensers, debotanizer, a net overhead cooler, and naphtha splitter, net head overhead coolers. Air-cooled exchangers includes the compressor interstage cooler, air coolers, debotanizers, condenser, and naphtha splitter condensers must be put into operation prior raw oil is sent to the reactor riser. Okay. Check instrumentation and commissioning any instrument not already in operation. Okay. Stop wet gas compressors. Prepare to start up the gas compressors in accordance with manufacturer instruction. Number 1. Purge all air from the compressor prior to unblocking the suction and discharge lines for both stages. Number 2. The lubricating oil and seal oil system should be in operation prior to manufacturer recommendation. Allow the pressure in compressors to equalize with the connecting pipe and vessels by opening the bypass around the suction valves, that is stage 1 and 2 sides. Check the compressor's casing drain to remove any liquid. Close the net sponge gas control valves. Begin to bring the compressor on the accordance to manufacturer procedures. Watch the pressure in the FCC main column, overhead receiver, the compressor suction drum, and the interstage receiver carefully. Add fuel gas as necessary to maintain pressure. Number 7, the compressor should be running with sponge gas control valves must be closed. Okay, inventory vessels with gasoline. Once vessels are under pressure with a fuel gas, they can be filled with gasoline and internal circulation can be established. This will allow smooth control of levels and flow while feed is being started from the main column overhead system. The initial inventory is provided through the normal operating flow scheme. Number 1. Prior to introducing gasoline, establish the steeper pressure higher than the debotanizer pressure by 2.7 bar G, 40 psi. If possible, the steeper bottoms are pressurized to debotanizer and there must be enough pressures available to allow a flow between the two columns if circulation is to be established. Number 2, startup gasoline is introduced to section of the main column net overhead pump. When the main column receives is filled and level is stabilized, a gasoline can be brought into a primary absorber using the net overhead pump. During the pre-startup circulation, it may be desirable to use the line to top tray of the primary absorber so that all trays are filled with gasoline. Number 3. Start the flow slowly and do not lose the level in the main column receiver. Continue to make up gasoline flow from sponge as necessary. Okay, FCC unit startup, heat up the steeper and debotanizers. The steeper is warmed up by introducing steam to the column. Heat to the debotanizer is supplied from the main column. It is desirable to warm up the reboiler on these vessels prior to startup if possible. This is for the reboiler of the debotanizers entirely depend upon available heat from the main column. Okay, begin a small flow of heavy cycle oil through the debotanizer reboiler. It may be necessary to use the control valve bypass on the HCO flow to limit heat removal from the main column. Number 2, watch the bottoms level so as to not boil away all the gasoline and monitor the debotanizer temperature. Do not overheat the column. Okay, number 3, slowly introduce LP steam. Number 4, the bottom levels and the temperature in the steeper must also be monitored to avoid problems. Filling of sponge absorber and establishing of LCO circuit has to be done later when the LCO is available from the main column and the absorber steeper section has reached as a reasonable pressure. Okay, next topic, introduction of feed. Okay, introduction of feed. When raw oil is fed to the reactor risers, excess gas will be produced almost immediately. There will be a small delay of few minutes until a liquid hydrocarbon feed to the primary absorber increases significantly. Number 1, Increase the pressure of the absorber steeper sections 12.5 bar G, operating pressure, and the process gas from the main column overhead system, line up LCO unit or sponge absorber and establish a circulation. Number 2. Pressure control setting on the main column receiver should be 0.6 bar G, which is about to 0.07 a bar, 1 psi below the overpressure vent control or to the flare. Number 3. As the gas is processed through the compressor, a level will begin to build up in the compressor interstage suction drum. Commission the compressor interstage condensate pump to control the level in the drum. Number 4. Begin awash water injections with a 12.9 meter cube per hour. It depends on the capacity or design flow to the interstage cooler, which is approximately 7 volume percent of projected feed rate to the FCC unit. As the water level builds up in the high pressure receiver, place the level control in operations to pressure the sour water or main column condenser. Okay. As the unit pressure begins to build, place the lean gas pressure control valve in operations. When the pressure reaches the desired set point, the controller should begin to control the unit pressure. Number 6. As the liquid hydrocarbon feed is received from the main column receiver, switch the flow to the feed distributor above a tray ton of the primary absorber. Number 7. The recycled gasoline flow back to the suction of the pump should be switched to the top tray to primary absorber. Place the intercooler of pumps in operation. Number 8. Increase heat input to the steeper, debutanizer and naphtha splitter in order to establish a normal operating temperature. Begin a flow of naphtha to treating unit as the level builds in the bottom of the splitter. Number 9. As the pressure in the sponge absorber builds up, begin in rich oil flow back to the LCO, returns line to main column if it was not possible establishing this earlier. Okay. Introduction to feed. A liquid hydrocarbon feed is received from the main column receiver, switch to flow to the feed distributor above tray ton of the primary absorber. Number 7. The recycled gasoline flow back to the suction of the pump should be switched to the top tray of the primary absorber. Place the intercooler pump in operation. Number 8. Increase heat input to the steeper, debutanizer and naphtha splitter in order to establish normal operating temperature. Begin flow of the naphtha to the treating units as the level builds in the bottom of the splitter. Number 9. As the pressure in the sponge absorber builds, begin the rich oil flow back to the LCO, return lines to maintain column if it was not possible to establish this earlier. Conclusion. This is my conclusion page, what we have discussed today. First, a charge oil to the reactor riser, operation of catalytic cooler. Number 3, line out the fractionation section. Okay, gas concentration sections, air free vessels, start cooling waters and overhead condensers. Number next, start wet gas compressor. Number 9 and 10, inventory vessels with gasoline. Next topic, we are going to discuss FCC unit on operation. Okay, these are a few references here. Okay, please do not hesitate to send me your feedback, comments, t.masood.dr@was.edu. Thank you very much and stay blessed.